Hello friends, good morning. In previous lecture, we studied about distance and displacement. What is the difference between distance and displacement? Unit of distance and displacement. Today, in this video lecture, we study about uniform and non-uniform motion. Clear? First of all, uniform motion. Okay? A moving object is said to be in uniform motion. Uniform motion if it covers equal distance, in equal interval of time, in equal interval of time. Clear? Time interval may be small or large. So if you want to write this definition in more details, then we can join some words also, that it is of time howsoever these howsoever small these time intervals may be. Clear? Our definition will be completed at this point also. A moving object is said to be in uniform motion if it covers equal distance in equal interval of time. However small these time intervals may be, means that the time intervals may be very small, but if in small time intervals also the object covers equal distance, then the motion is said to be in uniform motion. Time interval we can take large for hours, 2 hours, 3 hours, or we take the time intervals second, milliseconds, etc. It depends on observer that the observer take small interval of time or large interval of time. But condition for uniform motion is that the moving object would cover the equal distance in equal interval of time. If moving object covers equal distance in equal interval of time, then the motion of object will be uniform motion. Clear? If we plot a graph, then it will be a straight line. Suppose that x-axis shows time and y-axis shows distance. Time distance. covered distance. This is time and distance. The time is in second. 1, 2, 3, 4, 5, 6, 7, 8. And the distance in meter. We take a parameter. Scale for time. One piece equal to 1 second. जो एक पीस है इस लेंथ का 1 सेकंड शो कर रहा है और मीन डिस्टेंस के लिए है और डिस्टेंस जो 1 पीस ऑफ लेंथ है इसको क्या कर रही है 5 मीटर। 5 10 15 20 25 and so on. Body starts from this point which is 0 0. Means time is 0 and cover distance is 0. As our watch tells us that 1 second passed, the object reaches from this point to this point, means it covers 5 meters. In next second 1 to 2 it reaches again 5 meters is 5 meters. In next second 2 to 3 it reaches 15 is 5 meters. In next 3 to 4 15 to 20 and so on. If we make a graph between these points, then we find a straight line. We find a straight line. So it clears that from the graph the graph for uniform motion will be a straight line. Uniform motion. Clear? Means the object, for example, if you are running on a smooth road and you covers 100 meters in each second, in each consecutive seconds, then your motion will be uniform motion. Now we discuss about the non-uniform motion. Non-uniform motion. A moving object is said to be in non-uniform motion when it covers unequal distance in equal interval of time. in equal interval of time. However, small the intervals of time may be. For example, if a person is going on the road, in first second he walks 5 meter, in the next second he walks 7 meter, in next second he walks 8 meter, in next second he walks 10 meter, in next seconds he walks 2 meters. Here the time interval is same, 1 second, 1 second, 1 second, but the distance covered by the person is different. Means the same interval of time but different distances. Then the motion of that person is called non-uniform motion. The graph of non-uniform motion is a curve. Time in second, second में x axis और distance मीटर में आपको जो ग्राफ होगा कुछ इस तरह से आएगा, which will be a curve. Clear? What is the difference between the uniform motion and non-uniform motion? In uniform motion, interval of time, in same interval of time, the covered distance will be same, but in non-uniform motion, the interval of time will be same, but the covered distance will be different. Clear? Now, we will discuss what is scalar and vector quantities. Scalar and vector quantities. So first of all, we discuss about what is physical quantities. Physical quantities are those quantities which can be measured directly and indirectly, and the law of physics can be explained in the terms of these quantities, or we can say that in other words, all those quantities which can be measured directly or indirectly, and the law of physics can be explained in the terms of these quantities. The physical quantities are categorized mainly in two categories. First, scalar quantities, and second, vector quantities. Scalar quantities are those quantities which are completely described by a magnitude alone. Scalar quantities are those quantities which can be described completely by magnitudes, but vector quantities are those quantities which cannot be completely described only by magnitudes, but for the complete description we have to write the directions also. And in simple words, we can say that vector quantities are those quantities which have magnitude as well as direction also. Means magnitude and direction both will be mentioned to describe any vector quantities. Now we write the definition of scalar quantities. Scalar quantity. Scalar quantities. Scalar quantities are those quantities scalar quantities are those quantities which can be described by magnitude 1, by magnitude 1. Here means it has no need to mention the directions, means these quantities do not have the directions. Clear? For examples, mass, time, length, volume, spectrum. In general, scalar quantities are those quantities which have only magnitude. Clear? Now we discuss the vector quantities. Vector quantities. Vector quantities are those quantities vector quantities are those quantities which cannot be described only by magnitude, for describing the vector quantities we have to mention the direction also. Vector quantity equal to, we can say that magnitude plus direction. Means a vector quantity is that quantity to describe which we have to mention magnitude and direction both, but scalar quantity is that quantity which can be explained only by describing the magnitudes, the complete information it gives. But for vector quantity, if we do not describe the directions, then the information is incomplete. Example, force. As in earlier classes, class 8, you have learned that force is a vector quantity and the direction of force is that in which it is applied. North, south, east, west. Clear? Displacement. Second one is example is displacement, acceleration, etc. are the examples of vector quantities. Clear? Now, in next video, we will discuss about the graphs related to position time, velocity time, and acceleration time. Thank you.